Hello my dear students, how are you? Namaste to all. Again you are giving you very important reaction about ammonia. That is what she asked in examination. So I only talk about the important reaction about the ammonia. So what is the important chemical reaction of ammonia. Yes. So first one is reaction with water. Yes. So reaction with water. So what we see when ammonia is reacted with water. So what to get? Ammonium hydroxide. That is ammonium hydroxide. Yes. Now this ammonium hydroxide on dissociation, what we have? Ammonium plus, that is hydroxide ion. Ions, yes. And due to presence of hydroxide ion, we can say ammonia is due to presence of hydroxide ions. We can say ammonia is basic in nature. Yes. So if it is base, so react with what you see? React with, so in this again we can write reaction with conc HCl, hydrochloric acid. Generally asking what's examination. Also you do perform this experiment in the lab. So reaction with conc HCl. So what we have? So when ammonia, you know that is the base. When react with conc HCl, that is acid. So what we get? Ammonium chloride. What to get? White dense fumes like clouds. You know about the clouds? Yes. That is the first reaction with water. And sometimes ask you, how can you show ammonia is basic or alkaline in nature? So we have to see the reaction. Then also you have to give the one reaction with what's conc acid. If sulfuric acid, what to get? Ammonium sulfate. If nitric acid, what to get? Ammonium nitrate. Yes. Suppose what's conc sulfuric acid? So what we see? NH3. When react with conc sulfuric acid, what we have? Ammonium sulfate. So what we see? Ammonium sulfate, how much? 2. So what we have? 2. Yes, ammonium sulfate. So always keep in mind, generally acid base is reacted, what we get? Salt and water. But when you talk about the ammonia and the reaction with acid, always give the resistance salt, never give the water over here. Yes, first one. Second one is reaction with chlorine. So what do you see? Two condition over here. If suppose NH3 is excess and suppose chlorine is less, or we can say limited. So what we have? ammonium chloride plus nitrogen, generally asked in examination. So what we see, NH3 when chlorine, what you get, 8, 3, 6. Yes, so you can balance by a heat and trial method. Never learn what to see is balancing. B, if the condition is just reverse, what we have, NH3 is less and chlorine is excess. So what do you get? Nitrogen trichloride plus HCl, that is nitrogen trichloride. Yes. So what do you see? So if the condition is reverse, so what you get, product is also some new. So NH3Cl2 how much versus 3 and 4. In this case Cl2 2. So what we have to do, nitrogen is 1 over here, hydrogen is 3 over here. So what we have to do, we have to balance, what you see, 3 suppose 3 Cl2 suppose 2 NH3. So what do you suppose? So what you get, 2N 6H. So what you see, chlorine is 6. So 2 C's are 6, so not balance. Balance, better to see. Three Cl2, yes, 3 Cl2 NH3 and say 3 HCl. Yeah, that is balance. It's not necessary to learn by heart what is balance. Yes, we have to try it. Yes, and sometimes we have not getting the word say balance, then leave it and go further. So this is about the reaction with chlorine. So it's very important. Next one is as reactant. As reductant means reducing agent. So generally in exam, what generally asking what happens, so always we have to give the language. First, when ammonia is passed over heated cupric oxide and lead oxide separately we get copper and lead metal respectively by reduction process like so what we see, suppose cupric oxide when must be heated, otherwise no reaction. So when ammonia gas is passed over heated cupric oxides, so what to get, copper, that is arrow indicating downward means PPT, solid formation, plus side product is what you see, water. Yes. So in this case oxidation number of copper is +2, in this case 0. Likewise, when you talk about lead oxide, also what is heated? So what is ammonia? What do you get? Again reduction. So what do you see? Pb arrow indicating downward. What do you see? H2O. So plus 2 oxidation number, in this case 0. So what do you see? Reduction over here. What do you see? Reduction, also reduction. Yes, balancing. So what do you see? 2 NH3, 3 cupric oxide, 3 copper, and H2O is how much? 3 H2O. Yes, like this, 2 NH3, 3 lead oxide, 3 copper. Yes, so that is about the reductant reactions. Very, very important and generally asked in the examination. So I think you have clear as reductant. Next one is reaction with 4. Reaction with what is sodium metal. Sodium metal. When ammonia is reacted with that is also important. All are the very important for examination. So with sodium metal we get sodamide, hydrogen gas, like so. Reaction is like this. So always we have to give the words language, then we have to give the balanced chemical equation. So what we have? Ammonia plus Na. So what you get? Na NH2, that is soda lime. Sorry, sodamide. Sodamide plus what you see? Hydrogen gas. What do you see? 2, 2, 2. Yes, 4, 6 to 6. So that is balance. Yes. 5. So what do you say? Reaction with mercurous nitrate solution, that is the test for ammonia. Test for ammonia. Yes. So what do you see? When little language, when ammonia is reacted with mercurous nitrate solution, we get so what you see? Reacted with mercurous nitrate solution, we get black PPT, precipitate, better to say black precipitate of mixture of mercury and ammono basic mercuric what do you see? nitrate. Like, that is very, very important and generally asked in examination. So, what we have? Mercurous nitrate, Ag2 nitrate. In this case, one mercury has one oxidation number, that is mercurous nitrate plus what you see, ammonia. Mercurous nitrate plus what you see, ammonia, plus water also need. So, what to get? Amino, NH2 means amino, that is nitrate, 2Ag. So, that is what you get, black PPT, plus side product is ammonium nitrate. Yes, balance of this one. So, what we have? Balance is 2, 2, and what we get? 4, H2O, so what you see? 3, that is the ammonium nitrate, Yes. Next one is six, very important, reaction with Naylor, chemist, name of the chemist, Naylor's reagent. Yes, that is also the test for ammonia. Yes. So, what we say? At first, we have to know, sometimes ask you, what is Naylor's reagent? Give is one use. So, answer this question is like this: alkaline solution, alkaline solution of dipotassium mercuric tetra iodide is known as what is it? Naylor's reagent. It is used to detect ammonia. Formula of Naylor's reagent is molecular formula is what you see, K2HgI4. OH means base, dipotassium mercuric tetraiodide, that is known as Naylor's reagent. That is known as Naylor's reagents. Yes. So, reaction is like this. So reaction is involved like this. So what we have? K2HgI4 plus ammonia. Always we have to see the what is the base. So 2NH3 balance. 3 what to get? 2Ki plus HgNH2 iodide. That is the amino mercuric iodide. Amino mercuric iodide plus what we see? Ammonium iodide. Yes, two-step reactions. What we have? AgNH3 iodide plus what is water. Condition is same. Basic condition. So what we get? Complex compound HgO. HgO, HgNH2 iodide plus. So what we plus what we get? Ammonium iodide. So when balance this one, so what we see? Multiply by 2. So what we get? So what we get? 2Hg, H2O, HgO, yes. So what we get? Overall or net reaction you can say. What to get? Overall reaction K2 HgI4 yes, K2 HgI4 plus 2 molecule, and what to get? 4NH3 plus H2O, alkali conditions. What we have? HgO, Hg amino iodides. What type of PPT? Black PPT. Sorry, reddish brown, and that is also known as Milon's base. Milon is the name of the chemist, plus that is the arrow indicating downward, plus 4Ki plus what we see? (3NH4) iodide. Ammonium iodide, that is ammonium iodide. Very important for examination. So I have cleared what are the Naegele's reagent and what the function of this one. Yes. Next one is 7. So what is say? What is complex formation? That is also very important. Formation reaction. Yes. So generally ask you with saturated copper sulfate. Yes, always keep in mind So when ammonia with water always gives ammonium hydroxide. So first what we have, NH3 react with water and what we get, ammonium hydroxide. Yes. Now this ammonium hydroxide react with copper sulfate, ammonium hydroxide. So what we get, copper hydroxide plus what we see, ammonium sulfate. Yes, what you see, bluish with white PPT. Yes. Now this one, copper hydroxide plus ammonium sulfate plus, that is the less, in this case less, and in this case excess. So what to get, tetraamine, copper, how many ammonia over here, 4 plus sulfate, 2 oxidation number pairs plus what, see, water. So what's tetraamine? What's the name of this compound? Tetraamine, copper. How many charge over here? 2. Copper, second state, sulfate. Its color is what you see? Deep blue, or we can say indigo color. We know about the indigo, nil, indigo color. Yes. So what we get, tetraamine, that is very very important. So after balancing, what we get, NH4, 2 NH4 OH, NH4 OH, copper hydroxide, ammonium sulfate. What you see, 2 NH4 OH, 2 NH4 OH. So what we have, copper tetraamine and how much, 4H2. That is complex compound. Yes, a generally complex ion is written inside the large bracket. It too shows it has 2 positive charge, 2 oxidation number. Sulfate has 2 negative charge, you know. So that is what you see, reaction with copper sulfate, generally asked in examination. B, with silver chloride, that is silver chloride. So what we have, AgCl, excess, so you know, NH3 plus H2, what we have, ammonium hydroxide. Yes. So what you get, Ag diamine, how many, 2 amine over here, large bracket, 1 positive charge, and what you get, chloride, that is diamine, silver, first means oxidation number is 1, chloride. Yes. So after balancing, what we have, after balancing 2 NH4 AH, so what we see, Cl 2H2O, AgNH3 plus 2H2. Yes. Next, 7. What is the precipitation? Reaction like heavy metals ions. Heavy metal ions like ferric chloride when treated with ammonium hydroxides. So, what we get plus what we say, that is reddish brown ppt. Yes. So, what we say, balance what we say, how many NS4, 3 OH. So, we have 3 NS4 OH. Yes, 3 NS4Cl. Ferric chloride. Next one, suppose what we see, aluminum chloride. Aluminum chloride, ammonium hydroxide. So, what we get, aluminum gelatinous, like starch you can say, gelatinous white PPT, precipitate, plus side product is what you say, ammonium chloride. After balancing, what we have, 3 same NS4Cl, and what you get, 3 NS4Cl. Yes. Next one is chromium sulfate. Chromium sulfate. Chromium sulfate when treated with ammonium hydroxide. So, what we have, chromium hydrochromium, balance of chromium is 3. So, what we get, green colored PPT. PPT means precipitation. And what the product, what we say, ammonium sulfate. So, after balancing, what we have, chromium 6 NS4 OH, 6, 2 chromium hydroxide plus 3. Yes. Next one is what we say, chromium zinc sulfate, ammonium hydroxide solution, that is also aqueous solutions. What we have, zinc hydroxide plus ammonium sulfate. So, what is it? What type of PPT? White PPT. The arrow indicating downward means PPT. So, what is it? 2 yes, that is balance. Yes. Next one is 8 number, reaction with air. At ordinary conditions, what we have, NH3O2. So, what we get, nitrogen plus steam. Yes. So, what's the color is, greenish yellow flame. What type of, greenish yellow, balancing, what we have, what you get, 4 NH3, 3O2, 6H2O, 2N2. Yes, one condition. Second one is AB, catalytic oxidation in presence of catalyst. So what you see, NH3 plus O2, platinum catalyst at 800 to 900 process is oxidation in presence of catalyst. So what you get, N mixture of NO plus steam. So reaction is what we have. So what you get, 4NH3, 5O2, 4NO, 6H2STO. Yes. Eight reaction. Yes. Next one is 9. Reaction with CO2. So when NH3 CO2 150 degrees centigrade, 150 atmospheric pressure. So what do you get? Urea fertilizer. That is urea fertilizer. That is also known as inorganic amino methanemite. Methane plus what we see, H2O. So balance, after balancing, so what we see, 2NH3, what you see, balance already. Next one, 10, reaction with what you see, with bleaching powder, generally used in as a disinfectant. So what we have, so 3CaOCl2, that is bleaching powder plus ammonia plus, and this is the sign of heat. So what we have, calcium chloride plus N2 plus 3H2. So these all are very, very important reactions. So I think so we have to practice all these because they are very, very what is important for examination view of points. So I think you practice it. Yes. So thank you for visiting, watching this interesting video, and also I think you have subscribe it and also convey your students or friends, your relatives for learning. So for have a nice day. So be happy, be healthy, be bona fide in chemistry like Sheila Sir. Yes.